Let's look at the section objectives for section 2, unit 3. By the end of this section, you should be able to 1. Determine whether or not any set of matrices can be added. 2. Determine whether or not any one of any two matrices can be subtracted from the other. 3. Find the sum of compatible matrices. And 4. Find the difference of two compatible matrices. Let's look at matrix addition. Two matrices can only be added if they have the same size. This means that the two matrices that you want to add must have the same dimension. If the first one is a 2 by 2, the second one should also be a 2 by 2. If the first one is a 2 by 3, the second one should also be a 2 by 3. To add the matrices, we add the corresponding entries of each of the two matrices. For example, the first matrix is 2, 3, 1, 5, 7, 4. And this is being added to another matrix which is 5, 4, negative 1, negative 2, 1, negative 3. The first matrix is a 2 by 3, and so the second one is also a 2 by 3. So the first entry in the first matrix is 2. The first entry in the second matrix is 5. So we can do 2 plus 5. Then we get 7. The second entry in the first matrix is 3. The second entry in the second matrix is 4. So we can do 3 plus 4 and we get 7. We do that for all the entries, and when we finish, we have a new matrix which is 7, 7, 0, 3, 8, 1. We want to look at some of the strategies involved in matrix addition. So if you are going to add the same matrix repeatedly, twice, thrice, or 4 times. If you are adding it 2 times, all you do is that since it's the same matrix being added twice, you use 2 to multiply the whole matrix. If you are adding it 3 times, you use 3 to multiply it. If you are adding it 4 times, you use 4 to multiply, so that you don't add the same thing 4 times or 3 times. So let's look at the example there. The matrix is 2, 3, 1, 5, 7, 4, and it is being added 3 times. So instead of repeating it 3 times, you use 3 to multiply the matrix. The 3 is now a scalar, so it will multiply each of the entries of the matrix. So 3 will multiply 2 to give you 6. 3 will multiply 3 to give you 9. 3 multiplies 1 to give you 3. Then 3 will multiply 5 to give you 15. 3 will multiply 7 to give you, and 3 will multiply 4 to give you. That becomes the answer for that addition. In general, if you use a scalar to multiply a matrix, as we have seen in the previous example, the scalar must multiply each of the entries. So if you have k, for example, multiplying the matrix, then you have 2k, 3k, you have k, you have 5k, 7k, and 4k. Let's look at this example. Find the value of k such that k into bracket 2, 3, 1, 5, 7, 4, bracket closed, is the same as the transpose of 2, 5, 3, 7, 1, 4. I would like you to give a try to this one before we get to the solution, so that you can compare your answer to what we will have. Let's look at the solution to the previous question. We will finish and then you will compare your answer to what we have done. We'll start by finding the transpose of the 3 by 2 matrix, which is 2, 5, 3, 7, and 1, 4. And its transpose becomes 2, 3, 1, 5, 7, 4. And now that we get the transpose of this 3 by 2 matrix, it now has the same dimension as the first one that k is multiplying. So we can now equate the two, because we are told that k multiplying that matrix will be equal to the transpose of the 3 by 2. So when we equate it, then we use the scalar to multiply each of the entries. And then for equal matrices, corresponding entries must be equal. So the first entry at the left hand side, which is 2k, should be equal to the first entry at the right hand side, which is 2. So we can simply say that 2k is equal to 2, and so k is equal to 1. We can use any other entries to do the comparison to find our k. I hope you got the same answer. We move away from addition to subtraction. And to subtract two matrices, they should have the same dimension. If you take the difference of the two matrices, it will give you another matrix that is of the same dimension as the ones that are subtracted. So, if you have the matrix 2, 3, 1, 5, 7, 4, and you are subtracting another matrix which is 5, 4, negative 1, negative 1, negative 3 from it, then as we did with addition, you subtract corresponding entries. So the first one will be 2, which is the first entry of the first matrix, minus 5, which is the first entry of the second matrix. And so that will give you negative 3. Then the next one is 3 minus 4, and that gives you negative 1. The next one is 1 minus negative 1, and that gives you 2. Then you come to the second row. 5 minus negative 2 will give you 7. Then 7 minus 1 will give you 6. And then 4 minus negative 3 will give you 7 as your final answer. We did repeated addition. We also want to look at repeated subtraction, so that if a particular matrix is subtracted a number of times from a given matrix, all you have to do is to take the number of times it is being subtracted, use it to multiply the matrix, get the answer before you subtract that final answer from the given matrix. So for example, you have the matrix 2, 3, 1, 5, 7, 4. And there is another matrix that is being subtracted from this one twice. That matrix is 1, 0, 1, 2, 1, 3. You don't have to subtract it and subtract it again. All you have to do is to use the scalar 2 because you are subtracting it 2 times. So you use the scalar 2 to multiply that matrix. And then you now subtract that answer from the first matrix from which it is being subtracted. So we have 2, 3, 1, 5, 7, 4 minus 2 times 1, 0, 1, 2, 1, 3. So we repeat the first one. Then when we use the scalar to multiply, we know it must multiply each of the entries. So we have 2, 0, 2, 4, 2, 6. We now do 2 minus 2. That is the first entry in the first matrix minus the first entry in the second matrix. So that gives us 0. Then we move to the second entry, 3 minus 0. Then we get 3. Then the third one, 1 minus 2. We get minus 1. Then we come to row 2. 5 minus 4. We get 1. 7 minus 2. We get 5. And then 4 minus 6. We get negative 2. Let's consider example 6, which says, find the values of m and n such that the matrix A, which is A, B, C, row 1, D, E, F, row 2, is the same matrix as the difference between 6, 6, 1, row 1, 7, 8, 8, row 2, and the transpose of 0, 5, row 1, 3, 4, row 2, 2, 4, row 3. So we look at the solution. The matrix A is equal to the difference between matrix 6, 6, 1, 7, 8, 8 and the transpose of the 3 by 2 matrix. So you first will have to find the transpose of the 3 by 2 matrix. And that transpose is 0, 3, 2, row 1, 5, 4, 4, row 2. So we will subtract that from the matrix that has been given. So we have 6, 6, 1, row 1, 7, 8, 8, row 2, minus 0, 3, 2, row 1, 5, 4, 4, row 2. And as we always do, first entry of the first matrix minus first entry of the second matrix. So we have 6 minus 0, we will have 6. 6 minus 3, we have 3. 1 minus 2, we have minus 1. 7 minus 5, we have 2. 8 minus 4, we have 4. And then 8 minus 4, another 4 as the final answer.